Uh, I will make my presentation on of axis electric field of uniformly charged ring using the symmetry and invariance study and Coulomb's law. This approach is a new approach in physics. Is a subject of purely in physics. I am Bendaoud Saad, PhD from Laval University. I am associate professor at Cadi University, Morocco, North Africa. Introduction. In this paper, our goal is to determine the component of the electric field vector of the uniformly charged ring at any point in space in cylindrical coordinate. We can do this also Cartesian coordinate or spherical coordinate. The expression of the component are obtained in terms of the complete elliptic integrals of the first, second, and third kinds. We introduce limiting cases and approximations in plane and on axis electric field vector. This is the setup, and we say x, u, z axis, and we have on P here when we want to determine the electric field vector in the space. This is the range, the uniform charged range. And we take a segment element near pi parameter. And we use the by symmetry. We found that the implicit expression of the field vector is as this chart. It has two components only, not three, in the space. And we use the Coulomb's law. This is the Coulomb's law, and we must find R minus R prime divided by this quantity to put it here. And we must decomposition in the setup here. We make composition of R prime and R vector position. And we found that R prime is as this expression, R as this expression for the symmetrical coordinates, where rho is equal to R sinus theta, and Z is equal R cosine theta, and R minus R prime has this expression, and the modulus of R prime has this expression. We can put this quantity now here, and the Q also. And by replacing those quantity where Ka is equal to 1 divided by 4 pi epsilon 0, when the epsilon 0 is the permittivity of the vacuum. This is the value. And we found the Coulomb's law has this expression in 3D motion. But we can make a changement to pass to the coordinate. This is the Cartesian coordinate. We can use the You listen me, I don't see my transparent. I don't see my transparent. No transparent. There is no explain why. Okay, see this. And the calculation give us 0 for the azimuthal component. And we can raise it from the expression. This expression simplifies to this equation, and we can make the calculation to find the expression, the final expression. We make this changement of variable, and we put this changement in the integral. We find this form. We make mu equal to k square 2 equal to this quantity here, and where q equal r square 2 plus o plus square 2 plus z square 2 plus 2 o r. And we continue the calculation. We found this expression. And we must now calculate this component, the radial component, and the axial component. After, we must calculate now the axial component of the electric field vector. And we see here that this function is the elliptic integral, the complete elliptic integral of the third kind. This form here, where n equal m equal k square 2, we have this form, and this form is exactly this form here. And we can, and this form also here, and we can replace this integral by its expression, and we found finally the expression of the axial component of the electric field. Radial component of the electric field vector calculation, and we take this equation and we manipulate it. It gives us this free integral with some, or make sum of rho and r here. He gave this, the term leads to this term, and this term it remain. And after we make some manipulation here to change, to modify it, to change it. And we found this equation. Finally, we make calculation. We found the complete elliptic integral of the second kind, the elliptic integral of the first kind. Their plot are here. And we make replacing, and after we found the mathematical expression of the radial component of the electric field. But the azimuthal component is 0. We show it. We show this in this already here. And those are the components of the electric field. Limiting case, we found and the arc and the plan that the expression of the electric field radial component, but the axial components is 0. And this expression is here. We make a discretization, and you put this in the computer. We find the plot of the electric field as a function